There are many tools for doing one-dimensional and two-dimensional plotting, and these tools can be standalone packages, or they could be a library, let's say in R or in Python. And one-dimensional and two-dimensional plotting is actually quite different from three-dimensional visualization for a number of reasons. Well, first of all, when you're doing something in 1D or 2D, it's very easy to show these on the two-dimensional screen. And also, three-dimensional visualization can be quite expensive computationally. So if you have a large three-dimensional data sets, and by large I mean multiple gigabytes and tens of gigabytes, then it can actually take a significant time to process and render that data set. So this is very different from a typical line plot or a bar chart that you would create in 1D or perhaps in 2D. In the next few slides, I'm going to show you several examples of one-dimensional and two-dimensional Python packages. And for many visualizations, they are really sufficient. So for many visualizations, you don't really need to use something like ParaView, because ParaView was specifically designed for three-dimensional visualization of very large data sets. Also, I want to stress that it is really a good idea to use open source tools for visualization, because nowadays pretty much anything you want to visualize, you can do with open source tools. This is very different from a situation 20, 30 years ago, where open source tools were not that well developed, and you had a number of commercial packages, and everybody had to use commercial packages for complex visualizations. Today, the situation is very different. There are lots and lots of really wonderful open source tools, and it just does not make any sense to lock yourself into any commercial tool for visualization. A few years ago, a researcher from France, Nicolas Rogier, created this beautiful plot that shows various Python visualization packages broken by the renderer. So matplotlib, the one that you see on the right, is a very popular rendering package or plotting package for Python that was developed almost 20 years ago. And it was designed for creating static visualizations, so basically for creating images, bitmaps or PNG files. So with matplotlib, you can create a static visualization and a series of images, and from this you can create a movie. But these are static visualizations in the sense that you cannot interact with them. So JavaScript engines on the left will let you actually create a static HTML5 web page that you can load in your web browser. You will see your visualization there, but then you can interact with your visualization. So you can mouse over and get some more information. You can switch on and off various layers, etc., etc. And then there is OpenGL in the lower left corner, which is typically used for more complex three-dimensional visualizations. So in OpenGL, you can offload your rendering to a graphics card, to a GPU, and that way your rendering will be done faster than on a CPU. So there are many rendering packages that are based on top of OpenGL, and ParaView that we're going to study is one of them. As you can see, there are quite a lot of overlaps between these three rendering engines. And I'm actually going to show you, I'm going to talk in a little bit more detail about some of these packages in the next few slides. Just a brief example, inside the codes directory, you can find the code adaptive.py. And what it does, it takes a mathematical function, and then a one-dimensional mathematical function, and then the left edge of integration, the right edge of integration, and a tolerance to which you want to compute the integral of this function from a to b. And then it computes the integral. So it will do it adaptively. It will place more quadrature points into regions where the function is oscillating a lot. So for example, in this case, we have sine of 1 over x, and it is oscillating a lot near x equal to 0. So there are more quadrature points, and then the script adaptive.py computes the integral, and then it creates a plot showing the function along with the integration points. So all of that takes about 40 lines of code, and all plotting is done with matplotlib. So this is a typical example of one-dimensional plotting, where you have a function of one independent variable. Here's an example of two-dimensional plotting in Python. In this case, we have the image, a PNG image, picture of a mountain. And then this is a PNG image with three filters. There is red, green, and blue. And we're taking the blue signal, and we're calculating its gradient. And then we're plotting the square of the gradient on the right and saving it as a PNG image. So all this processing is done with a library called Python Imaging Library, PIL, and this just gives you a typical example of two-dimensional plotting you can do in Python. The Matplotlib package for one-dimensional and two-dimensional visualizations that I mentioned before is really the most popular package for creating simple plots in Python. And if you Google Matplotlib gallery or simply click on the link at the bottom of the slide, you will get a page with hundreds of examples, thumbnail examples of simple visualizations. And then when you click on one of them, it will give you the Python code behind that visualization. So you can use it as a template for creating whatever you want. Matplotlib produces static visualizations. It produces static images that you cannot interact with. If, on the other hand, you want to produce dynamic visualizations, you have a number of choices. One of them is an open source but commercially supported library called Bokeh from Continuum Analytics. It's a Python library. You use it to produce static HTML5 web pages with JavaScript and data embedded right into the page. Then you open the page in a web browser, you see a visualization, but you can interact with the visualization. So you can mouse over any element, and that will give you more information. You can zoom in, you can zoom out, you can pan your image, you can turn on and off various elements, etc., etc. So it's a dynamic, interactive web page. Plotly is a similar package. Plotly was actually developed by a Montreal-based company with the same name, Plotly. And they wrote this engine that actually has APIs for many different programming languages. So you can use it from Python, from R, from JavaScript, MATLAB, a few other languages. And the idea is very similar to Bokeh. You write the Python code, and when you run it, it'll create an HTML5 web page. You load it into your browser, and you see there your interactive visualization. For many different types of visualizations, Plotly is actually more than enough. So if you want to create a heat map, a line chart, a scatter plot, all these simple things. For that, you don't really need ParaView. You can Google Plotly Gallery or click on the link in this slide, and it will give you many examples of Plotly visualizations. You can click on one of them, and you will see the Python code behind that visualization. So in this course, we're going to spend a little bit time, maybe 15, 20 minutes, starting Plotly, just to give you an idea of what kind of simple visualizations you can do with it. And for that, you don't need ParaView. But the main subject of this course, of this workshop, is really three-dimensional visualization with ParaView.